It comes from an Arabic word that basically means, it comes from the name of a famous, I'm forgetting who. It comes from the name of some guy. Anyway, it's the current meaning of algorithm is a process for solving a problem. Computer programs use algorithms. Logical means it makes sense with logic.
Don't you use an algorithm to solve the Rubik's Cube?
Yes, you can.
Did they outlaw vowels halfway through this word or something?
Yes, they did actually.
Okay.
Yeah, logarithms has no vowels at the end.
That's weird. And I don't
Yeah.
like it at all.
Okay. Little tiny bit of backstory here. Logarithms may be the most brilliant discovery / invention in math for one simple reason.
Is that an I or an R?
That's an I.
No, the other
That's an R.
No. Other word.
Logical algorithm. Up here?
No, down.
Logical. I.
Logical.
I.
That's an I.
Logical. No, I.
Okay, now. All the major discoveries of math.
It doesn't look like.
Logarithms.
Guys, we're done discussing that, okay? All the major discoveries of math have some predecessor. Even things like the Pythagorean theorem. You can find ancient texts that show the Sumerians were thinking about it. What Einstein did was based on the work of others. Newton, Descartes, they were all building on other things. As near as anyone can tell, Sir John Napier woke up in Scotland one day and just asked himself, what if exponents worked backwards?
Ew.
We can't find any historical evidence of anyone else even asking this question. This may be the most original math idea ever. Sir John Napier, late 1500s, crazy Scotsman.
Why can anybody think like that? What do you mean?
Well, it's like all the great math discoveries, you can find someone else they were building, upon whose work they were building. Even if you go back to the ancient Greeks, you can look at ancient Sumerian tablets that have like ideas on it. You can find ancient Egyptian tablets that have early ideas, and you can see a continuity. Einstein would say, I'm building on the work of so-and-so. Isaac Newton, who was considered the greatest mathematician in the 1700s, had a quote that said, if I have seen farther than others, it is because I have stood upon the shoulders of giants. And he was referring to how he was building on the work of people like René Descartes and others. This guy, there's no evidence of that. What I'm about to show you, he came up with entirely on his own, and there's no evidence of anyone else even discussing the question before him, which may be unique in the history of science and math. Napier, he was nuts. Brilliant, rich Scottish guy, lived in a castle.
How can it make sense that they just created it?
You'll see in a minute. Here's hoping. Here's hoping you'll see in a minute. For one thing, he was the kind of guy who would think of this. He had a problem. His neighbor's pigeons were eating all of his seeds out of his gardens. Now, this is the late 1500s. This is not a minor annoyance. This
Why
is
were they his neighbor's pigeons? Why couldn't they just be God's pigeons?
Well, that's the thing. He was sure it was the neighbor's pigeon, and the neighbor was sure it was random natural pigeons. They had a big argument about it. But the thing is, you got to understand how serious this dispute was. This wasn't like an ornamental garden. This is like whether or not you eat vegetables all winter. You know, it's not like you can go down to the Whole Foods and replace what the pigeons destroyed. So, in order to prove it was his neighbor's pigeons, he took his seeds one month and he soaked them all in grain alcohol. And the pigeons came and ate the seeds.
Grain alcohol? So
Yeah.
the pigeons or the seeds?
The seeds, excuse me. And the pigeons ate the seeds, and the pigeons got drunk and passed out in his yard.
Oh.
And then the neighbor came charging down the 50 miles from the next estate, banged on his door and said, did you do something to my pigeons? And he said, oh, you mean the pigeons who are not responsible for devastating my garden? They're out back sleeping off their hangovers. Take them home and keep them out of my garden. The kind of guy who thinks of stuff like that
Is it genius?
is a bit of a genius. A
Wait, did you do
logarithm,
that to an animal?
It
It
doesn't
were
have anything to do with logarithms.
not directly. Inverted exponents.
How does the neighbor have pigeons?
Okay, now we're done. Inverted exponents. Okay, here's a fairly simple statement, I hope. 5 squared equals 25. Is there anyone here who has any questions about what this statement actually means at this point in your math career? 5 squared means 5 times 5. 5 times 5 is 25. Yes, Sarah?
Why is the 2 smaller than the 5?
Its mother didn't get the appropriate prenatal care for a healthy number to be born and raised.
So it's legally small.
What's the name of this guy who invented?
Sir John Napier.
Does John Napier did he have questions about why that worked?
Or ask me that
just-
again in a few minutes and
Okay.
see if this clarifies it or not. Okay, you guys know this part is called the base.
Yeah.
This is the power up here.
So the
is
smaller
what
the
you
more
get.
power you get.
Pardon?
Never mind.
Yeah, you keep dreaming. Here's how Napier rearranged it. He rearranged this statement to say the log base 5
What?
of 25 equals 2.
Wait, what is log?
That's really irritating.
It is. Log is his shortening for logarithm, and it's a rearranged statement so that the answer is the exponent. Here's the most important thing I want you to hear and get about logarithms. This is the biggie. This is honestly how I will explain it for the next few weeks, how I'll constantly refer back to it.
Wait, so if you have 3 and 2?
Amy, wait. The answer is the power. The answer is the power to which something is raised. There is no difference between 5 squared equals 25 and the log base 5 of 25 is 2. The question a logarithm asks is 5 to the what power equals 25. Okay, now this looks like an arbitrary, irritating, as Phil put it, I think, rearranging for no purpose. But I'll show you some of the purposes in a moment. If there are no other purpose, then, Amanda, didn't you say these are on the ACT?
Yeah.
Okay, so there's one purpose right there. So if I ask you for other logarithms, remember the answer is always the power. Answer is always what's in the exponent spot. So if I say log base 4 of 16, 4 to the what power is 16? 2. Not 4 times 4. 4 to the what power?
Wait, I don't get the little
Power
four.
the answer.
Yep, because this is a rearranging of the statement. This is a rearranging of the statement. 4 squared equals 16.
Oh, so
And the 2 is the power here.
So
The
you
2 is the answer of the logarithm.
So you just figure out which power goes to what.
Yeah.
the big numbers. So like 5 squared would be 25.
5 squared would be 25. Yeah, these have changed positions in a way. The base here is now the little number.
So like if you had if you had log 8 and then 64, would your power be?
The log base 8 of 64 is also 2. Yeah, with squareds, these aren't that hard, because you guys should know your squareds. They get a little bit more annoying, like, here's an example that's not going to be 2. What is the log base 3 of 27?
7.
7.
7 times 3 would be 21, and 3 to the 7th power would be
9.
here. It's not multiplication.
Three.
Okay. It's 3. Why,
Oh,
Jeremy?
I got it.
3 cubed is 27.
Because 3 cubed is 27.
Couldn't you just do square root of 27 on your calculator and got the answer?
No, because we're not talking about square roots. We're talking about cube roots.
Oh, man.
Alright, so your calculator can do logarithms, but it's a little bit different.
So this is a way of doing cube roots, squared roots, and every other power in the same format, like without like.
Back afterwards.
Do you know?
Yeah.
Do you know what I'm saying?
Yes, yes.
This is so confusing. Why did you do it if you got the same answer?
I know, that's a totally valid question.
Because he was an 8 back then.
No, that's not it at all, actually.
He wanted to boost his ego and make himself feel smart, so he figured out something new, even though it was useless.
It's actually not useless. In fact, basically, what this eventually led to was really the graphing calculator of the 1600s. This was the dual core chip of his time.
Oh, you mean the little, like,
Not the abacus. No, it wasn't actually a machine. I'm speaking metaphorically. Okay. It's going to take me a few minutes to get you guys to the point where I can show you how this sped up certain calculations. But first, I want to do a couple more examples. And these are going to be meant to confuse you a little bit. Remember, the answer is always
25th.
the exponent. What is
So
the
would
log
answer be
base?
2?
No, because 25 squared is
It would
625.
be like point something.
It would be like point something, right? What would
Or negative, right?
be a fraction? You guys have done fractional exponents.
But how do you find that?
1/5, right?
Not 1/5. You're still thinking division. Think powers.
Oh,
Next.
1.
Yeah.
Point 2.
1/2. Jeremy's getting good at this game. Because 25 to the 1/2 equals 5.
Oh, because the square, if you undo that, it's square.
Yeah. Yep. Isn't that kind of neat?
No.
You guys have no sense of math poetry.
Why would we do
Math is
that?
not poetry.
Math is just the.
Mr. Bobo, I don't understand why it goes down to when it's positive, Laurie.
Which part? Well, you know this is to get